Hey everyone, welcome to another video in our Year 7 Prime Numbers / Introducing Indices series. So in the last couple of videos, we talked a lot about prime and composite numbers, as well as starting to draw out these prime factorization trees. Now, we're going to take a quick detour to talk about something we've loosely mentioned in other video series, particularly in Year 7, and this is the idea of indices and how we can use them. So, sorry, let's take a moment to talk about indices. Now, indices, you may remember, before we talk about indices, we've mentioned before the idea of squaring numbers. So this type of shorthand we write for if we had, for example, 3 times 3, we wrote this as 3 squared, where the number up here was just the amount of times our number was multiplying by itself. So I have 2 3s multiplying by each other. So therefore 2, the amount of times, the amount of 3s we have here, that would go up here. Now, that is what we call the power. So when we write this in the form, for example, 3 squared, we want to break this down into a couple of different elements. Now, this is important because we're dealing with some new language here, and this is going to be the building blocks for what we call indices, what we're going to be looking at very, very soon in this video. Now, the two elements here, I have this thing up here. So this is what we call the power. Now this, from what I showed before, is just the amount of times this same number was multiplied by itself. And the number down here, this is what we call the base. So what our new type of notation, our new way of writing this particular thing tells us is that it gives us the base, which is the number that's being multiplied, and the power, how many times it's being multiplied by itself, or how many of these 3s are timesing together. So here we have 2. Now, you may be noticing a bit of a pattern here, where if you think back to multiplication, for example, when we had, we talked about this in another video series, we talked about this idea of multiplication being an abbreviation for addition, a type of shorthand way of writing addition of the same number. So for example, 2 plus 2 plus 2, we wrote that as a shortcut as just saying, well, we have 3 groups of 2 or 3 times 2. This thing here, my multiplication, was a shorthand, a shortcut way of writing this. We talked about the example of an abbreviation. So let me actually make a quick note of that. So multiplication is a shorthand way of writing the same number added together a certain amount of times. Together, a certain, we'll write number of times. Now, our powers here and what we're going to now call indices, this is another type of shorthand, another shortcut way of expressing a lot of multiplications. So if I had, for example, 2 times 2 times 2, well, if we follow the idea of squaring, Well, we said a number multiplied by itself, we can write that as the base number, 2, squared to the power of 2, in which the power, what we talked about up here, tells us how many times it was multiplied by itself. And we can express for no matter how many numbers here, we can write an abbreviation, a shorthand way of expressing multiplications of the same number. In the same way, multiplication gave us a shorthand way of writing the same number added. So we're looking at all shortcuts here, right? The moral of the story really is that mathematicians are lazy, right? We don't want to write out all these operations. Imagine if this 2 was multiplying another, I don't know, 50 times. We're not going to write that all out. We want a shorter, more condensed way of expressing these big pieces of information. So all we're going to do here is we're going to look at the base. So what's the base? Well, the base is just the number that is being multiplied. So here we can see we have all 2s. So my base here is going to be 2. And we want to count, well, how many 2's do I have here multiplying by each other? And we have here 1, 2, 3 2's. So I can write this as 2 to the power of 3. My base number, which is the number that is timesing by itself, and the power, this 3, the amount of that same number we have multiplying by itself. Now, this is a nice shortcut way of expressing information. You can see my thing on the right here is a way shorter and quicker way than writing 2 times 2 times 2. So there are 2 different forms that we can express this idea of this operation of multiplication. So one of these is what we call our expanded form. So this is the long way of writing this, right? This is what we call our expanded form. And the shortcut way, the shorthand, is what we call index form. So indices. Indices is the plural for index. So here we have index form. And this index form and this idea of indices, what we're introducing in this video, is the idea of expressing numbers in a shortcut type of way. So let's try a couple of questions going both ways. And then at the end of the video, I'm going to talk about some common misconceptions. So it'd be useful for you to listen out for that, because a lot of students make mistakes here. But the examples, I'm just going to do one of in terms of each way of converting. So say we had here, let's go, what would happen if I have 8 times 8 times 8 times 8 times 8. Now, what's this currently in? Well, this is in expanded form. I can see this is my long way of writing this. Now, all I need to do to convert this to index form is figure out what the base is. And here, pretty obviously, we can see these are all 8s multiplying. So my 8 is going to be my base. And I want to count how many 8s I have here multiplying by one another. So I have 1, 2, 3, 4, 5. So the number 5 is going to be my power, my number I put up here. And you can see as these expanded forms get bigger, it's going to be a lot more useful to write these in a condensed way. This is why we need indices here. Now, let's try going the other way. So if I had, for example, in question 2, say I had 5 to the power of 6, and I want to get this back into expanded form. So I'm starting with index form. I want to get back to expanded form. So to do this, well, I'm just going the other way, right? My ideas still apply. So what's my base? Well, it's 5. So 5 is going to be the number I'm multiplying by itself. And the power 6 just tells us how many 5s I need to include for these multiplication operations. So all I have to do is just write out 6 5s, all multiplying by each other. It's as simple as that. So 1, 2, oh, sorry, I have 6 5s. So 3, 4, 5, 6. That is all we need to do to go back and forth. Now, let me give you one more example. It's going to be a little trickier, but the same ideas apply. So what if I had 3 times 3 times 2 times 3 times 2 times 3? Well, let's think back. What is the only way I can use this shorthand? What's the one condition that I needed to write this in the shorthand way in the first place? Well, what I needed was I needed all the same numbers multiplying by one another. That's the only way I can use indices, this shorthand, this abbreviation for multiplication. So the only way this is going to work when I simplify it is when I multiply the same base. And you can see here I have 2 different numbers, 2 different bases. But all I need to do is, well, I just want to see how many of each I have. I want to collect the same bases. So with my 3s, I have 1, 2, 3, 4 3s. And how many 2s do I have? Well, I have 1, 2 2s. So to write this, nothing really changes, guys. The only thing is we have to consider more than one base that's multiplying. So I have 4 3s, so I can write this with a base of 3, and I have 4 3s multiplying by each other. So my 4 is going to be my power up the top here. And remember, all of these operations are multiplications. So I'll do this a longer way as well. This is like saying 3 now times 3 to the power of 4 times 2 times 2. Just to give you one more extra step. And now this particular thing here, I can write in a shorthand way because I have 1 and 2 2's here. So let me write this particular thing here in a shorthand way. Well, I have my base of 2. And how many times is 2 multiplying by itself? Well, 2 times. So that's the power. I have 2 2's multiplying. And notice here, my multiplication operation stays. I haven't actually done anything to get rid of this. And my 3 to the power of 4 stays this way. So I've condensed this multiplication with different bases into still a nice little compact thing to work with. And this idea is going to be pretty important when we start looking at applying this back to prime factorization trees. But for now, let's quickly just look at some common misconceptions with indices. And let's write this here. Common misconceptions. So common places where students sometimes confuse the ideas of indices. So we'll write common misconceptions. And the first one is that 2 to the power of 3, for example, a lot of students get this confused and go, oh, okay, well, this is the same as 2 times 3. Now, if you've followed everything so far, you can see why this is wrong, but let's just quickly talk about it. My shorthand here, my use of indices, this is a shortcut for writing multiplication of the same base number. This thing here, even though it uses the same numbers, this is a shorthand for addition. So this particular first thing here is a shortcut or an abbreviation for 2 times 2 times 2. And this thing here is saying I have 3 groups of 2. So that's the same as going, well, 2 plus 2 plus 2. And here I get, going down one more thing, 2 times 2 times 2. Well, 2 lots of 2 I get 4, and 2 lots of 4 I get 8. And here 2 plus 2 plus 2 equals 6. So none of these are equal. I'm drawing it with this particular symbol. So the first common misconception is that 2 to the power of 3, for example, is not the same as writing 2 times 3. They're two completely different operations. Now, another thing that students get wrong, so this is misconception number 1. And misconception number 2, so another common mistake, is that students say, sometimes they get a bit confused and they go, okay, well, if I have 2 times 4 squared, well, that's the same as going, okay, well, I know 2 times 4 is 8, and let me just leave the squared up there. So a lot of the time students go, okay, 2 times 4, I know what that is, that's 8. And let me write that as a squared. But we need to consider here, guys, what are our abbreviations, our shortcut things, this bad boy here? What's that actually telling us, right? This is just saying that my 4 squared is the same as writing 4 times 4. And that is being multiplied by 2. So what I get here, and on my right-hand side, 8 squared is like writing 8 times 8. Now, 4 times 4 is 16, and 2 times 16 gives me 32. Now, 8 times 8 gives me 64. So you can see that that's not the same, that's not the same, and that therefore is not the same either. So this is a rule with how we use indices. We need to be careful, guys. I know it's a shortcut, but students often get really keen to do all these operations and just use the shortcut, but we have to understand what that shortcut is telling us. This bit of information, 4 squared, is telling us this. So it's different to multiplying just this by this and then leaving the same power there. So even consider with order of operations, when we work with a question, for example, like, I don't know, let's do one more example to help you with this misconception. 3 plus 2 times 4 squared. Let's do a different number. Let's do 5 squared. We kind of want to deal with the abbreviation first, right? We want to deal with the shortcut first. So this thing is the same as saying 3 plus 2 times 5 times 5. Because by definition, 5 squared is a shortcut, abbreviated way of writing 5 times 5. And then now here, we can just use our BODMAS. So I went through this in more detail in another video series, but 2 times 5 times 5, that I want to do first. So 2 times 5 gives me 10, times 5 gives me 50. And then now I can finally add, because multiplication is a shortcut, an abbreviation for addition. So addition is going to come last. But guys, the main idea I want to get to here is, with this particular misconception, is that we need to consider the definition of our powers, of our indices. This thing here is not the same as 10 squared, as just multiplying the bases and leaving the power. In doing that, we're ignoring the definition that we talked about at the start of this video, which is, what is the idea of writing things in index form? Well, it's an abbreviation for multiplying same base numbers. This particular thing here. So in the same way, multiplication is a shorthand way of writing the same number added together a certain amount of times. Indices and index form is a shorthand way of writing the same number multiplied together a certain number of times. Now, we're going to keep talking about these ideas in the next video when we apply this to prime factorization trees. Thank you so much for watching. I'll see you in the next one.